Assalamu alaikum wa rahmatullah. Welcome to the Al-Kisa Foundation podcast. I'm Ali and I'm going to be your host. Today I'm going to be having a hallway conversation with a friend of mine, Shayan Doroudi, about education. We're not going to talk about any particular content or curriculum, but instead focus on the broader topic of education through the lens of technology. Shayan is an assistant professor at the University of California, Irvine School of Education, with a courtesy appointment at the Department of Informatics. He does research at the intersection of educational data science, educational technology, and learning sciences. He received his bachelor's in computer science from Caltech and his master's and Ph.D. in computer science from Carnegie Mellon University. Welcome, Brother Shayan. So good to have you here.
Thank you. Assalamu alaikum.
Alaikum salam wa rahmatullah. I want to take us back to 2011, 2012, when you saw this explosion of MOOCs. I think that was around the time when MOOCs really exploded. What were your thoughts in those days, and where are MOOCs now, and like what exactly happened in that time? And if I remember correctly, back in the days, everybody thought that MOOCs is going to take over the world, and we thought that universities would completely shut down and that there's no need to have in-person universities anymore. But the reality couldn't be further from the truth. What happened there?
So I wouldn't say everybody thought that, but I think there was definitely a lot of media hype and a lot of hype promoting that idea, and so a lot of people were probably influenced by that. I'm sure at the time I was also on the I would say on the optimistic side about MOOCs. I don't think I thought that it was going to replace traditional institutions. Some people did. Some of the advocates for MOOCs I think claim that, but or predicted that. But I think probably there was also a lot of critics, and at the time I don't think I was necessarily reading like the critics' perspectives or people from education researchers, what they were thinking. But I'm sure there were a fair share of critics at the same time. But yeah, I think so. A lot of the hype was just, it's funny because the technology was not drastically different than what could have been done earlier. It's not like it's not like they were using some like new technology like AI or something that came out. They were just basically delivering, again, these recorded, lectures to online, right? So they're basically putting lectures online. And before that, before MOOCs, there was things like MIT had OpenCourseWare where they put up some of their courses online. I'm sure there were a lot of things like that where people were putting up recorded lectures online. The main difference I think with MOOCs was that, or one of the main differences was that those were recorded lectures like in a lecture hall where the instructor was writing on a chalkboard or a whiteboard. It was not designed as an online course. And then also I think they were typically not really classes. They put up their lectures, they put up their assignments, but it's like, hey, do whatever you want with it, right? There's no like assignments, there's no deadlines, things like that, that you have to do. So it didn't have a course structure. But again, the technology could have allowed for that. It's just people weren't doing that, right? So with MOOCs, it was just people realized, oh, why don't we make courses specifically designed for an online audience? And these are instructors at top universities like Stanford, right, who started it. And so I think why I got a lot of hype was tons of people signed up, which was they weren't expecting. So I think one of the first courses, which was what became Udacity, they had an artificial intelligence course. They had, I think, if I remember correctly, maybe like over 100,000, maybe almost 200,000 people from across the globe sign up. So it's like, okay, this is attracting a lot more people than would take this course at Stanford, and it's people across the globe. So I think one of the like really promising things that they saw in it was that I think Sebastian Tron from Udacity, he said that it was like democratizing education. Now everyone has access to high quality education, right? In reality, that hype didn't live up. So what people realized later on is that, yeah, a ton of people sign up, much fewer, smaller numbers actually complete the course. And later research showed that the people signing up are often people who have master's degrees, maybe even master's or PhD degrees. They tend to be from more developed countries. So it's not like these people who never had access to an education are the ones that are mostly signing up for this, right? There are some people like that, but it's a lot of times people who want to supplement their existing Ivy League education with a new course that they didn't.
The initial launch of MOOCs reminds me of the internet in the 1990s,
yeah,
where, for example, New York Times would literally upload pictures of the newspapers onto their website. And so when people go to the website, they would literally just see a picture of the New York Times articles. And that wasn't very effective, but it didn't mean that, online was not effective, right? So later on, when they started digitalizing all this text and when they started putting the text in digital format, in a nice user-friendly format, that's when things started to kick off.
Okay, all this hype was there, and then what happened, right? So and the set of courses is growing. Like if you look at it from one perspective, it's like they're growing, right? Because they have more courses, they have more, but the hype has completely like sort of died down, right? Nobody, like, I actually asked my students, I teach a class in education technology. I asked my students at some point, like in the class, like, how many of you know what MOOCs are? Actually, like, I think very few of them know. I've like even heard of these things. So it's like, there isn't much hype, even among university students. They don't really know what they're about. So I think there's a few reasons this happened. Again, they weren't offering something drastically innovative necessarily. It's just that people hadn't really done that before. On the other hand, another thing I mentioned is that a lot of the people taking these are people who already have degrees. It's not like they're reaching out to the people who necessarily don't have access to a good education as much. And then and with Udacity, it's actually reaching out to people who want to get like jobs in Silicon Valley, right? It's not like their model has changed quite a bit.
People with deep pockets typically.
Yeah, or people who want them at least. But I think another thing is that a lot of the hype around this is one of the reasons. This is one of the areas I focus on now, is that a lot of these new ventures, these like MOOCs, and we can think about other technologies before that in education. They're not aware of the history of educational technology and how similar things people propose these kind of things, and they say, oh, this is going to drastically change education, and then it has some impact, it has some hype, but after a few years, people forget about the technology. And that's happening right now with MOOCs. So I think this is just a trend that generally happens. Education is very slow to change. It's not a system that just drastically changes overnight because you can do something fun online. So we have to be sort of authentic to that. And there's still room for improvement. There's still room, again, Udacity and Coursera still exist. They still reach out to some students, right? Or some people across the globe. But we just have to realize when we come up with a new idea in education, we have to realize that it's probably not going to change the system drastically. And we should think about what are ways that we can actually make it have more of an impact. So I think that's something I've come to realize over the past few years.
This is a great time to transition to talking about your thesis and what you're working on right now. Let's talk about your thesis.
I mean, I don't know if my thesis is that interesting, but I guess I'll talk about, I guess, sort of what I focused on, what I was doing research on, which, the general area of it. So I was one of the big components of my thesis was on trying to. So actually, I guess this leads to an earlier technology that people saw a lot of promise in, which is intelligent tutoring systems. These are platforms that were developed, I think, often for K through 12, that are basically like some software that students can basically learn a subject in, and usually it's for topics, not always, but like for topics, let's say like math or STEM, science and math topics, where you can sort of give students step-by-step problems, lead them through solving the problems, helping them learn. So math is a great example because there's a very procedural way to do arithmetic, algebra, etc., or geometry. So basically walk students like step by step through, let's say it's trying to teach algebra, right? Some algebra, like solving linear equations. It walks them through that process, it teaches them the steps. If they get something wrong, they can get a hint or something, or they get some feedback for why they got it wrong and to try again. And then, so it's not just like, okay, you solve problems, you write down the answer and you get graded, right? Which is what a lot of times homework is like, right? Where you don't get, so some of the limitations with existing homework is you're not getting immediate feedback. You're not getting, you have to wait till your instructor grades it. Maybe they grade it, or your teacher, maybe they grade it 2 days later or a week later. So that by then it's not very useful to you. And you don't get feedback on a given step, right? So maybe I write my answer and it's wrong, but I don't know why it was wrong, right? It might be wrong because the second step because I forgot a negative sign somewhere or in the middle of it, right? So this system can give you feedback right when you need it. And some of the systems use like, basically they know how to solve the problem. So they can tell if the student's doing something incorrectly and can sort of guide the student back to the right way of solving the problem. So there's a lot of thought that went into this. These people started developing the systems in the 70s and 80s. Actually, they're not very new, but they're quite So again, this
70s and 80s. That's
so
incredible.
The 80s really is when it started taking off. I think actually, so computer assisted instruction. I think it's interesting for people to know. Computer assisted instruction started in the 60s, like before people even had computers, right? So the first systems actually, I for my thesis, actually, I looked into this history a little bit. The Stanford actually had a computer. One of the first, they actually developed, I think, the first sort of time sharing with like graphical displays. So they actually had a computer at Stanford that connected to displays, like you could say monitors, basically in schools, in some schools in the Bay Area. and they would basically, multiple students can work at the same time using the same computer. So that was a very novel idea at the time. This idea of time sharing was very new. It was like, I think in like maybe there was the mid 60s or something that they started doing this. So they had students in classrooms working, and then their answers would go, to the computer at Stanford. It would crunch some numbers or something, and then decide what to do, what to give the student next and things like that. So this idea was being explored in the 60s actually. So what I was interested in is working with some, like one of these tutoring systems. I wanted to see if we could make it more adaptive in terms of what problem it would give students next. So we were specifically working on a tutoring system that would teach fractions. Had a bunch of problems related to fractions, different topics on fractions. And we want to see, okay, for example, if the student repeatedly gets some kind of problem wrong, let's say they're trying to add fractions, they can't do it. Well, maybe we say, okay, well, why are they getting it wrong? Maybe they have to go back to this other skill that maybe they didn't really learn, right? Maybe maybe they don't even understand what a fraction is. We should make sure they understand what a fraction is first. So we might have to jump back a couple topics, for example. Or let's say a student's getting something right. Well, maybe we can give them a harder problem, give them some harder numbers. Oh, if they're having a hard time, maybe we go back to an easier problem, right? So there's many ways in which you can imagine, and a good teacher, how does a good teacher or a good tutor, let's say, so these systems are called intelligent tutoring systems because it's a one-on-one system. So what does a good tutor do, right? If they give you a good problem, if they give you a problem and you're struggling with it, they will try to diagnose, well, why are you struggling with it? How can I better explain this to you? Maybe I'll give you another kind of problem that you can see it from a different way. Maybe I have to give you an explanation. So that's the ideal of these tutoring systems, sort of, to be able to do that on the fly. And I was trying to do this. We're trying to use like machine learning. We had a bunch of data collected from students in elementary schools working on our tutoring system. We want to see if we can use this data to sort of like learn, basically like a model of how students are learning and how to sort of adapt instruction to the students. And I think there's a lot of hype around this idea right now. A lot of people are, some companies, I don't know if you heard of, there was a company called Newton, Knewton.
No,
a few years back. And they basically claimed they were doing, this kind of adaptive problem selection for students. And they had a lot of hype as well. And there was like an NPR article about them that the CEO claimed they had like a robot tutor in the sky. And I don't even know what that means. It's not in the. What does it mean that it's in the sky? But they basically that phrase just came.
Say in the cloud, probably.
No, I think you're just making stuff up to make it sound cool. I don't think you've done anything concrete with that. But in any case, it ended up like the company didn't really get. They had a lot of marketing, but not as much, I think, substance, I guess, to back it up. It seemed, and they didn't get much traction. They got acquired by some other company that basically it seems like they turned Newton into another product. Like they actually changed the product even. So in any case, so there's a lot of companies like this will pop up. Sometimes they'll stick around for a few years. Sometimes they'll die out. But a lot. So whenever I see someone claiming that they can do a good job of this, I'm skeptical because a lot of my thesis was trying to do this, and I actually did a literature review of all the prior attempts that people have tried to do this. I found some have been more successful than others, and this is actually what led me to realize that people are actually doing this in the 60s. They were actually using data to determine it was in a simpler task for like sequencing like vocabulary words. Let's say you want to teach someone Spanish or Arabic, and then you want to give them like words to practice. What is the best word to give the student next, right? So it's like a flashcard task, right? If I get this word wrong, I need to see it more often than if I get it right?
You say that they've been doing this from the 60s. Why is it still so difficult to build today?
Yeah, so I think there's a few reasons. One is, well, as I mentioned, people forget. So I think in the 60s and 70s, they were sort of working on this problem. Then they stopped, like that community that was working on this stopped working on this problem. And it came back up in maybe like the 90s. So, and basically, so people had forgotten, it wasn't like a continuous, effort sort of dating back to the 60s. So basically people forgot what people were doing back then, I think, in a sense. On the other hand, so for that particular problem of like sequencing vocabulary words, I think that's a fairly simple problem. You can do a pretty good job of it. But for more complicated problems like sequencing math problems, it's very difficult because math is a very complex subject. Different students might learn things differently. Different students have different prior knowledge, right? That they might have different, misunderstandings that they're bringing to the table. The data won't capture everything. Like a student might just, get distracted. They might leave the room. We think they're spending a lot of time on the problem. They're just working on something else, right? So like there's noise in the data. All of these things lead it to making it a very complicated problem to actually solve. So I think it's just what I've come to realize is that if you want to solve this problem in a very generic way, of trying to like, give students like a good problem, the best problem next. It's just very difficult because we don't have the right kind of data to make that decision, and we don't have enough of that data. Now we talk about big data nowadays. So even if we have data from like 1,000 students, like the complexity of the problem just makes it so it's not a very easy problem to solve.
Plus, like there's so many different subjects that you can't really narrow it down to just one.
Yeah, so each subject might need like a specific approach. You might need to model. So one way of doing this, for example, you model the knowledge, like how are different pieces of knowledge related to one another. And that's very subject specific. And once you have that model, you don't necessarily. So one idea is you can use data to fit that model, but a good like teacher might be able to construct that themselves, right? You don't necessarily need data to like discover that model. So if a teacher could give that model to the computer, and then beyond that, using data to refine it, it's not clear. Like you might need a lot of data before it starts making decisions. But there's actually one company that does I'll mention it's local here in Irvine. It's Alex, Aleks. And they do a really good job, I think, so they have this basically huge graph of math, how different concepts in math are related to one another. And what they do a good job of is they give us students like an assessment at the beginning, test, to basically figure out where in the graph these students are. So what does this individual student know? What do they not know? And they do this by, they use some like AI to basically figure out, to try to quickly figure that out. So they don't just give students like 100 problems. They'll give them a problem. If they can't solve this problem, they say, okay, well, maybe we have to test them on this problem here. And then if they solve this, well, then we know that they might know these things. So then we give them this one. So basically like give a small number of problems to quickly figure out what a student knows and what they don't know. And then
it's kind of similar to the Khan Academy, but with AI.
Yeah, in a sense, you can think about it. Yeah, Khan Academy has that graph, but they don't.
Right.
Khan Academy doesn't like. They might be doing now, but they don't. I don't think they were assessing students what they know. It's up to the student to decide. I want to practice this or not. So this platform just does a great job of like figuring out what the student needs practice on, and then it's up to the student like what order they want to do things in. It doesn't try to order those things, but at least it gives them a good starting point, right? So I think that's a problem that we can, I think, use AI to like sort of do a good job of. But the thing that I was trying to do for my thesis, I think that we might be able to find some particular areas like vocabulary, for example, sequencing vocabulary words, where we can use data to sort of give the right word next. But for very open-ended domains, and math isn't even open-ended. Once you get to like things like creative writing or like things like that, it's like how do we even develop a system that could teach that effectively or like sequence? I think people coming from a more technical perspective are often interested in what are the most state-of-the-art techniques that we can apply, like deep learning or whatever, blockchain, and we're going to use this to like revolutionize education. But in reality, you should be coming at it from what are the low-hanging fruits in education? What are the areas that need improvement? And what are the easiest ways we can improve them? So I think that's a great question. And I think in many cases, those things don't necessarily need a technical solution. So then the question is, well, if we want to see, okay, how can AI contribute, or other areas of computer science? Well, we should first find good educational problems and then see, is AI even the solution to this problem? If it's not, let's not try to pretend it is and waste our time with that, right? So I think, for example, just generally speaking, I think we should, and this is part of my thesis, was trying to combine AI and say machine learning and things like that with what we know about education, what we know about psychology, right? So I just want to go back to the idea of like sequencing vocabulary words. One of the reasons people are successful at that task is that we can have decent models for like how people forget things. And forgetting is very important for this, right? When you're trying to learn words like SAT words or something, the thing is like you might see a word, but the problem is you'll forget it like a minute later, right? So you want to basically quickly keep giving students words that they might forget. So we have decent models for how students forget, and that's coming from like psychology, right? Now we can refine those models with data, right? So it's not that we're purely saying, okay, we're going to use and people are actually trying to do this now. We're going to use like a neural network or some machine learning model to try to figure this out completely from data. We can actually use what researchers have already figured out in psychology and education related areas, and then combine that with techniques from AI to sort of refine that further. I mentioned the same thing with the knowledge graph, right? Let's start with the knowledge graph. And this is what that company, what Alex does. They start with a knowledge graph that, educators and experts have developed. And then they refine that with data. You don't just try to do it from scratch. But any area where we see, okay, there's an educational need, we have some ideas of how to do this, some idea, like we can look at the literature and psychology or education related areas to see, how can we tackle this problem? And then we can see how we can supplement it with techniques from artificial intelligence. Another area, for example, that I recently, some of my colleagues work on is trying to nudge students. So I talk about this problem of, especially right now with online courses, some students just fall behind. They have a hard time keeping, staying on top of everything. So what if you could just nudge students to tell them, oh, by the way, remember you have an assignment due in a couple of days. So one idea that people have been exploring is just to do that, just send nudges like every time they have an assignment due or something like that. Or if a student didn't turn something in, send a nudge. I just saw an article this morning that somebody developed a startup around this. Who's an educator who wanted to solve this problem. And he was initially just sending text messages to like parents to say, oh, your student didn't turn these in or was absent these days, right? So you could just do that. You can either send them to parents, you can send them to students. But then, and then they ended up making it automated. But I think there's room for, what if we can use machine learning to try to automatically figure out when should we send a student a nudge? Because if you send too many, they'll probably just get ignored, right? Like, when you get too many emails from someone or like from some organization or too many like notifications, you probably just start not paying attention to it.
Right.
Like every week.
That problem is already being worked on by all these other tech companies that are like social media tech companies, right?
Yeah. Sort of like personalized emails.
Notifications and whatnot.
Yeah. I think in education, there's a particular like, so again, we can use things that people are already doing in other areas, but I think that sometimes it needs to be tailored to this context, like the educational context, because the needs are sort of different, right? So similar with the recommendation, right? Like the recommendation problem, like Netflix, like recommending movies or other things. We do a good job of it in other areas, but in education, like recommending what problem to solve next. Because I mean, one way to think about it is this, that if you really want to know, like, okay, like what should I do for the student next? You ideally need a good model of how the student learns. And if you have a good model of how the mind works and how learning works, then you basically have a general artificial intelligence thing. If you can simulate a student's mind, then you basically have like a general or artificial general intelligence, which we're nowhere near having, right? So in a sense, like learning is a particularly complicated area to sort of, human learning is a particularly complicated area to study with machine learning, because it's very complex. It's basically intelligence and learning itself that we're trying to study. Whereas in other areas like human behaviors and things like that, consumer behaviors, they're just relatively simpler in a sense.
What are other things that you're seeing in this field that are very exciting to you right now?
I think other areas that are interesting and how to use tools to support like collaboration and things like that. Because a lot of the things I was talking about is sort of like one-on-one, right? Like a tutoring system that works one-on-one with the student. And there's been a lot of work as well. And I'm not as familiar with this work, but like computer-supported collaborative learning, where the computer is like sort of mediating collaboration between students. And that could be done in a physical space where two students are working together on a computer, or especially nowadays, well, how do we support students working together in a remote context where the students might be in different places, but and I think there's tools like for facilitating discussions among students and things like that. So there's a lot of work I think that can be done with natural language processing, where it's like you have natural text that students are typing. How do we like sort of understand what students are saying with this, and sort of, for example, facilitate the discussions that they're having with one another, see if their statements that they're typing, right, are reflecting an accurate understanding of whatever we're trying to teach and things like that. This is not an area I work in though, so I can't speak too much to it. Sure. I think for me, I think just promising areas would be things that facilitate more like the AI playing a more supportive role than trying to replace what teachers do, right? And I think this has been a tension. A lot of people are skeptical of bringing AI into the classroom, because it's like, well, we need teachers. We don't want to replace teachers. And we have this discussion with other jobs, right? AI is replacing jobs. It's replacing all these jobs. And a lot of people say, in a few years, it's going to replace pretty much every, jobs as we know it. I don't think it can or should do that with teachers. And I don't think a lot of the people developing these technologies, they don't claim it does. They do claim that we want this to sort of complement what a teacher does or supplement what a teacher does. But I think generally, so one of my colleagues, for example, I actually remembering this, I think this is one of the really most fascinating applications of AI that I've seen recently is he created these sort of like augmented reality glasses so again, it's students working with these tutoring systems, one-on-one tutoring systems in a classroom setting. So each student has a computer, and they're working on the same like platform that's teaching them some math subject at the same time. while the students are working on the tutoring system, the teacher can actually see. It's using like AI to determine for each student. For example, this student is struggling right now, or this student is like just messing around, right? And it'll tell the teacher, it'll give signals to the teacher, it'll like display like a question mark above the student's head, so the teacher will know where to go and give individuals attention. So I think something like that's really cool, where it's completely supplementing the teacher. It's completely complementing the teacher's role. It's helping the teacher do a better job of what they're doing. And I think that's a very promising area for people to look at for how AI can help, not to like replace the role of the teacher, not to do something better than the teacher does, but to sort of help the teacher do their job better. And one way could be like to help with grading, so the teacher can spend more time on more important things, right? But another way is to actually help like in the classroom setting, give the teacher some like real-time information or feedback to help the teacher and give more attention to students that need it. I think education is a really important and exciting place to work. And I think we actually need more people from our community to, I think, go into the field, not to become, I mean, we need people to be teachers, but I think more so to also go and study, education and educational technology is one aspect of it, which I would love to have more people, working in this area in our communities, but also just education more generally. Like, you can actually get degrees in education. I don't know if a lot of people are like, familiar with that, or like, that's not oftentimes what people consider when they're thinking of a career, right? Even if someone wants to be a teacher, they might not think to actually study education, or even psychology, which could be related in some cases. But so, I just want to encourage more people to think about that, and because it's an area that a lot of improvements can be made, and I think there's a lot that can be done in, even for example, like improving the type of education that's being done in Islamic schools, for example, and things like that. And so I think just people going and studying education, also the people who might be interested in developing technologies, who have a background in computer science or technical areas, to go and learn more about the educational aspect of things, to sort of more thoughtfully guide their approach and hopefully have a bit bigger impact in coming up with ways to improve educational systems.
Awesome. Well, thank you so much for joining me. Inshallah, we're going to wrap this up. بسم الله الرحمن الرحيم والعصر إن الإنسان لفي خسر إلا الذين آمنوا وعملوا الصالحات وتواصوا بالحق وتواصوا بالصبر صدق الله العلي العظيم.